In this video, we will be looking at async functions in depth. So the first thing we have to understand about async functions is async functions always returns a new promise instance. For example, let me create an async function. Now we can call this function and we can save the return value in a variable. Okay. Now we can just log the value. Now let's see the output. So you can see that the output is a promise instance and this is a fulfilled promise and the fulfilled value is undefined. Now where does this undefined came from? So if you look at this function have no statements, which means whenever we execute this function, it will just return undefined. Okay, if it is a normal function. But this time here it is an async function. So async function always creates a new promise instance. Now the thing that we have to understand is when it will be in the fulfilled state, when it will be in the rejected state, if it is fulfilling, what is the fulfilled value. So now you can see that here the promise instance is fulfilled and the value is undefined. That means the fulfilled value is the return value of the async function. So here in this case, we are not returning anything, which means the return value is undefined. That will be the fulfilled value of the returned promise. Now we can add a return statement here. So I'm returning the value 5 here. Now let me just save. And now you can see that again the promise instance is fulfilled and the fulfilled value is 5. Okay, now let's understand the rejection case. So whenever we throw anything from inside the async function, the returned promise instance will be in the rejected state with the thrown value as the rejected reason. Let's try that. Here I'm not throwing any error object, I'm just throwing a string and let's see the output. Now you can see that an error is thrown. So whenever a promise instance is rejected and if the rejected is not handled, error will be thrown. Now you can see that the returned promise instance is in the rejected state and the rejected reason is the string that we passed, which is error. So this is the rejection case. Now let's look at await keyword, how the await keyword works inside async function. For that, let me take another example. So here we have an async function and we are calling that async function at line number 12 and we have multiple console.log statements. Pause the video and try to predict the output. Okay, now let me save this file and see the output. So you can see that 3 is printed, then 1, then 4, then 2. So 3 is printed first, then 1 is printed, then 4 is printed, and finally 2 is printed. Now let's see what happens on each statement. Now line number 2 to 8, the async function is created. At line number 10, we have console.log 3. So this is a synchronous statement. So it immediately prints the value 3. Now at line number 12, we are calling the function test. What happens here? So inside an async function, till the first await statement, everything is synchronous, which means here we have console.log 1, so 1 will be printed after 3. And at line number 5, we have the await statement. So whenever it hits the await statement, it says that now suspend the function and execute the rest of the code asynchronously. Specifically saying the rest of the code is executed as a microtask. So in asynchronous execution, we can give the callbacks to the macro task queue as well as microtask queue. Since we are handling promises, so basically async functions are used to consume promises, promise callbacks are handled in microtask. So whenever we hit an await statement, the rest of the code is executed asynchronously and it will be executed using microtask. Okay, so test is called, one is printed. Now await statement everything is asynchronous now. Now we have console.log 4, so 4 is printed. Now the execution stack is empty. Now what happens? The event loop checks the microtask queue and it sees this part of the code is there. Now it will be taken from the microtask and will be pushed to the execution stack and will be executed. Now what is here? Console.log 2. So 2 is printed. Now let's add a return statement. So 1, 2, 3, 4. Let's return 5. And so we know that when we call an async function, it will return a promise instance. So we can call the then method to the return the promise instance. Now let's log the value. Now pause the video and predict the output. Okay, now let's see the output. You can see that the earlier output is same and 5 is printed at last. Okay, so from this we have to understand is that whenever the return statement is executed, then only the returned promise from this async function becomes the fulfilled promise, which means let's look at again. At line number 12, we have console.log 3, so 3 will be printed. And at line number 14, we are calling test. Okay, so the execution starts. Now this is synchronous, so 1 will be printed. And now the function is paused, which means at this point, this function returns a promise instance. And the execution of this function is not completed. It is suspended at line number 5, but it returns a promise instance. So the returned promise instance at this point will be in pending state. And we are calling the then method to a pending promise. So to a pending promise, if you are past this on fulfilled callback, which is not executed now, which is saved inside, this callback will be executed once the promise instance is in the fulfilled state. Now it is in the pending state. Now we have this await statement and the rest of the code is executed asynchronously, specifically saying in a microtask. Now what we have left, console.log 4. So 4 will be printed. So 3 printed, then 1 is printed, then 4 is printed. Now the execution stack is empty. So event loop gets the microtask and will be executed. So now 2 is printed and then the return statement is executed. Now when the return statement is executed, this promise instance will be in the fulfilled state. Okay, and the fulfilled value is 5. Now when it is in the fulfilled state, now this callback is executed and this callback is executed asynchronously, not synchronously. Even though the execution stack is empty now, the promise callbacks, the on fulfilled and on rejected callbacks are always executed asynchronously. So this console.log will be pushed to the microtask and the event loop sees the execution stack is empty, then it takes the callback and it will be pushed to the execution stack and it will be executed with the fulfilled value, which is 5. Now let's try to understand what exactly happens when we hit the await statement. So here you can see that the right side of the await keyword, we have a promise instance. So this await statement returns the fulfilled value of the promise instance. Okay, now so here, what will be the value? So here you can see that the right side of the await keyword, we have a fulfilled promise instance and the fulfilled value is undefined. So the value will be undefined. And let's just print that here. You can add it here and save it. And now see the output. Now you can see that 2 and then undefined. Even getting the value is also part of the microtask. Okay, that is important. Now let's give a value here. Just resolved. Now you can see that 2 resolved. Okay, not because I added the value here. So getting the value is also part of the microtask. We won't get a value immediately when the await statement is executed. So let me just change this, and I'm adding console.log here. Okay, so here value is not defined. You can see that now. Now see the order. So 3 is printed first, then 1 is printed, then 4 is printed, right? Now, like I said, the returning of the fulfilled value is also part of the microtask. Now, this is returned from this statement and it is printed. That's why we get resolved here. And then 2 is printed. Now, then 5 is returned. So we get the 5 from this log. Okay, so this is how the await keyword works. Now let me just change this promise.resolve call, and I'm giving a primitive value. Now let's just check the output. Now you can see that there is no change in the output. Even though we gave a non-promise value, it works. So with that, we understand that the await keyword doesn't need a promise instance. Okay, what happens exactly? So whenever we have an await statement, it internally does something like this. The value. So here the value is 6. So it gives the 6. Now this is converted to a promise instance. Okay. What about, so earlier it was promise dot resolve, right? Even in that case, internally it will be promise dot resolve, and the value is promise dot resolve. Now when we give a promise instance to the resolve static function, it immediately returns the promise instance. Okay, so here this call gives you this instance as it is. Okay, when we give a 5, this will be 5. Okay, so when it is not a promise value, which is a normal value, it will use this function to convert it into a promise instance. So that's what happened when we have the await statement. Now let's understand how the async function suspends and resumes later internally. So whenever a function is invoked, an execution context of that function needs to be created, and then it will be pushed to the execution stack. Then only the line by line execution happens. So that's the same case with async function as well. So when we invoke the async function, the execution context of the async function is created and it will be pushed to the execution stack. And when it executes line by line, and when it hits the await statement, now the execution needs to be paused, or the function needs to be suspended. How it does is that it saves the execution state or the current status of the execution context with everything, the lexical environment, variables, everything. It will be saved in the memory. Then the execution context is removed from the execution stack so that the rest of the code can be executed. So the interesting thing is the function is not executed completely. Before that, the execution context is removed, but it saved the execution status. So whenever we have await statement, it splits the function into separate states. That's how it internally handles it. So whenever the synchronous part in the script is completed, now the rest of the part needs to be executed, right? It is in the microtask. Now it will be taken from the microtask and it will be pushed to the execution stack. It continues. And when it continues, it needs the previous execution status. So that's why when the await keyword is executed, like when it hits the await keyword, it saves the current execution status before removing the execution context. Now let's understand how loops works inside an async function. So here is an example. Here is a function make delay which receives delay in milliseconds and returns a new promise instance, and the new promise instance will be fulfilled after the delay. So we are using set timeout function inside, and we are passing the resolve function and the delay. So the resolve function will be executed after the delay. Okay, now we have an async function here, and we have a list of delays, and we are looping through the delay, and we are calling make delay with the await keyword. So each time when we call the make delay, it returns a new promise instance. Now let's understand what happens here. So at line number 15, we are calling test. So test is invoked. Now we have the list of delays. And like I said, till the first await, everything is synchronous. So it the variable is declared and initialized with value 0, and it checks the condition, and the condition is true, and it enters the body of the loop. Now it will just print I. So what's the value of I in the first iteration? It will be 0. Now it hits the await statement. Now everything, rest of the execution is suspended. Okay, so the rest of the execution is in a separate microtask or executed asynchronously. Now in the main script, we have a statement here, a log, so which will print outside. So after 0 is printed, then outside will be printed. Now in the main execution, there is nothing. And of course, this test, when we invoke the test, when it hits the await statement, the, the current execution is suspended and it will return a promise instance. And the promise instance will be in the pending state, and we are calling then method to the pending promise instance. So this console.log is not pushed to the microtask yet. So this is a pending promise instance now. So 0 is printed, then outside is printed. Now the execution stack is empty. So then the microtask is executed next. And what happens here? So when it hits the await statement, it calls make delay. So it returns a promise instance, and the promise instance will be in the pending state because we have a delay, because the resolve function is executed after the delay. So once the resolve function is executed, the promise instance will be in the fulfilled state. Then only it returns the fulfilled value and the rest of the code is executed, which means in the first iteration, after 1 second, it will print the delay, which is 1000. Okay, and it won't stop there. It goes to the next iteration and it increments the value of I, and it checks the condition again, and I will be 1, and it enters the for loop, and then it prints the value of I, which is 1. Then at line number 8, it again hits the await. Now the function is suspended. Okay, now again, the main script don't have any synchronous statements. So again, the rest of the code is executed asynchronously in a microtask. Now, now the second iteration we are passing 2000 milliseconds. So this promise instance, returned promise instance, will be pending for 2 seconds, and after 2 seconds, it will be in the fulfilled state. Then 2000 will be printed again. Along with it will print the next value of I, and then it again hits the line number 8 and await, and after 3 seconds it will print the value of 3000, and after that, when the I is incremented and checks the condition is false, and it comes to the return statement. When this return statement is executed, now this promise instance is in the fulfilled state. Now this callback console.log will be pushed to the microtask and then will be removed from there and pushed to the call stack and executed with the fulfilled value, which is end. Okay, now let's see the output. See the behavior here. So 0 and outside is printed. After 1 second, 1 is printed. After 2 seconds, 2 is printed. Now after 3 seconds, end is printed. Now the total time taken here is 6 seconds, not 3 seconds. Why is that? You can see that each time when it hits await, It's so for the first iteration, it gets the first promise. So in that case, the second and third promise is not yet started. It's a sequential execution when we use await keyword with a normal for loop. This is really important because when we hit the await statement, it pauses the execution, it suspends. Okay, so once the first promise instance is completed, then only the execution resumes and the next promise instance is started. That's why the total time taken here is 6 seconds. Okay. Now this is the same case with for off loop as well. So if you change this to for off loop, let me change that. And there is no I here. So this will be delay. Okay. Now let's see the behavior. Outside 1 second, 2 second, 3 second. So total 6 seconds is taken. So here also it is sequential execution. Now let's use the for each method of the array instead of this for loop and see how it behaves. So I'm changing this to for each delays dot for each, and now we have to pass a callback function, and we get the delay here, and inside we have to use await, and we can call make delay with the delay, and we can log the delay. Okay, now you see we are using await keyword inside this anonymous callback, and the anonymous callback is a normal function. So inside normal function we cannot use await. So first thing, we have to convert this into an async function. So for that we can add async here. Okay, now you can see that in this whole code block we are using await inside this anonymous functions, which means this function can be a normal function. We are not using await inside, but let's just keep this way and pause the video and predict the output. Okay, now let's see what happens on each statement. Okay, so let's first execute this and see the behavior now. And I'm going to save this. Okay, total 3 seconds completed, and we get outside printed first, then end. This is the surprising thing. So end is here in the final return statement of the async function. So first outside is printed, then end is printed, then it is not taking 6 seconds like the previous loop situation. Here it is only taking 3 seconds total, and on each second 1000, 2000 and 3000 is printed. So what is changing here? Why is the behavior? So first thing here is we have an async function test. So the outer function is an async function, but we are not using any await. Okay, so when test is called, we said that till the first await statement, everything will be synchronous, and inside this function there is no await statement. Await is inside this anonymous function. Okay, so, it comes to the fourth line and it calls delays.forEach. We will see what happens when for each is called, and then it immediately comes to this 11th statement and it executes the return statement, and this promise instance will be fulfilled promise instance, and we are calling then method to the fulfilled promise instance. So this callback here, it is a console.log, is um, executed immediately asynchronously. So this callback will be pushed to the microtask. So this callback stays in the microtask, and now we have one synchronous statements left. So this is executed and outside is printed. Now after that, let's see what happens in this sixth line. So delays dot for each method is invoked, and we are passing one anonymous function. When we pass and execute this for each, what happens? Internally, there is a for loop, and on each iteration, this function is executed with the array value index and the whole array. Okay, that's what happens internally, which means it won't pause. Okay, on each for loop, the function is executed. Okay, the for loop is not blocked with it because the await statement is inside. Okay, which means it executes this function for the first iteration, then immediately it executes for the second iteration, then immediately it executes for the third iteration, which means three invocation is running parallelly. Okay, that's what happens. And on each function is executed, this one, the first one awaits for 1 second, and the second one awaits for 2 seconds, and the third one awaits for 3 seconds. But all the three promises starts its execution at the same time. Okay, so after 1 seconds, this is resumed and delay is printed, and after 2 seconds, 2000 is printed, and after 3 seconds, 3000 is printed. Okay, so that's what happens with the for each method. Okay, now, like I said, we don't need the async function here. Let's just change this to a normal function now. Okay, and so that we cannot call then method because this is not a promise anymore. But what we can do, we can just console.log here. Now, what will be the output? What will be the change? So the change would be this time, so that it immediately returns end and it is executed because this is now a synchronous statement. This there is no microtask involved in this. So end will be printed first, then outside will be printed, then the rest of the things like 1000, 2000, and 3000. Let's check this. So you can see that end is printed outside 1 second, 2 second, and 3 second. So that's the behavior with for each method. Now let's see some interesting edge cases with this async functions. So here we have an async function which returns the value 5, and we are calling that function, and to that returned promise instance we are calling the then method and passing the console.log. Now at line number 5 we have promise.resolve static function and passing the value 6 and calling then method to the returned promise instance, and we are again passing console.log. Okay, so what happens here? So test is called and a new promise instance is returned, and once the promise instance is fulfilled, which means that once the return statement is executed, the returned promise from this function will be in the fulfilled state. So what happens? This is a fulfilled promise instance and we are calling then to the fulfilled promise instance, and this console.log will be pushed to the microtask. Okay, now this is executed. Now, when this is executed, again, a promise instance, fulfilled promise instance is given, and we are calling then, and this console.log is pushed to the microtask, which means this is the first callback in the microtask. This is the second callback in the microtask. So the order of execution will be this will be executed with 5, and this will be executed with 6. So let's see the output. You can see that 5 is printed first and 6 is printed. Now let me change here. So instead of returning 5, I'm returning a promise instance. So you know that async functions always returns a new promise. Now from inside async function, I'm returning promise.resolve and giving the value 5. Okay. Now what will be the output? Pause the video and predict the output. Okay. Now this time, let me save this and see the output. Here 6 is printed first, then only 5 is printed. So what happens here when we return, when the async function returns a promise instance? Okay, so normally, let's first understand the behavior of promise.resolve first. So promise.resolve. So whenever we pass anything to the promise.resolve, it returns a new promised instance, and the passed value will be the fulfilled value of the returned promise instance. That's one case. But if we are passing a promise instance to the resolve static function, then the return value will be that promise instance. It won't process the instance further. So let me take an example. Let me save this const pr1, okay, and I'm giving 3, and console, okay, const pr2 is promise dot resolve, and I'm passing pr1. Okay, now console dot log pr1 pr2. Okay, let me just comment this one. Let me save this. You can see that it is true. Okay, so that's what I was saying. So this returns a new promise instance and it is saved in the pr1. Now pr2 is again we are calling promise.resolve with a promise instance. So it immediately returns the given promise instance. That's why these two instances are same. Okay, now here, now let's go check the above example. So here what happens? Now if you conceptually convert this, if it internally something like this, promise dot resolve, and what's the value here? This promise dot resolve 5. If it was internally something like this, then of course this immediately returns this promise instance and 5 will be printed first and then 6 will be printed. But that is not the case what is happening here. Here the case is that even though we are returning a promise instance, it will not be immediately returned like promise.resolve. It again creates a new promise and it processes the promise instance. So instead of this, it will be something like new promise. So it uses the promise class and we have the resolve function, and here it uses the resolve and passes the value. What is the value here? Promise dot resolve 5. So that's why it creates a new um, recursive function called internally. So what happens here? So if this is the case, first this will be executed. So promise.resolve will be executed and it sees that it's a promise instance and the callback will be in the microtask queue. Still, there is an outside promise. Its callback is not yet executed because it is in the pending state because we have a promise inside. So its callback is in the microtask queue. So that this callback will be the first item in the microtask. Then what happens? This is executed and this console.log will be in the second item in the microtask. Okay, now the execution stack is empty. Now the callback corresponding to the internal promise is executed. Okay, when that is executed, then only the outer promise, which means this one, will be in the fulfilled state and the corresponding callback again pushed to the microtask. So this becomes the next callback and that is taken from the microtask and which will be printed. So that's why in this case, 6 is printed first, then only 5 is printed. Okay, so this is an edge case that we have to understand with async functions. So here is an interesting edge case. So here we have an async function and at line number 2 we are using the await keyword and the value here is an object and it's not a normal object. The object have a function or method called then and it takes an argument, and this is a function of course, and at line number 4 we are calling that function with a value 15. Okay, so this object is known as thenable. Thenable means whenever we have a JavaScript object which is having a then method, then it is called a thenable. So what do you think the output here? So here we expect that the value will be this object. Okay, and you can see that this is not an instance of a promise, so obviously internally it will use promise.resolve static function and just pass this object. Okay, now that will be the value. So what happens if you pass promise.resolve at this object? So that's the case. So here we won't get the value as this object, but we will get here 15. Okay, so let's see the output here. You can see that 15 is printed instead of the object, and the return value is 5. That's from this console.log 5 is printed. Now what is happening here? So what if this is a promise instance? So if it is a promise instance, so internally it will be something like promise dot resolve, and if it is a promise instance, it immediately returns the resolve static function. So what about thenables, so like this? So whenever we have thenables, it actually considers as a promise instance, which means internally the promise API is not checking not only for the promise instance, but it also checks for promise like objects. Those are called as thenables. So if we have an object having a then method, it treats as a promise object internally. So which means what happens here is that instead of returning that object as it is, it calls the then method and it passes the resolve function to that then method. Okay. Now here, once this then method is invoked with the resolve function, inside the resolve function is executed with the value 15. So that becomes the fulfilled value. Even though this is not a promise, this is the fulfilled value and that value will be here. Okay. For example, um, this is not an async await behavior. This is the promise behavior when it handles thenable objects. For example, let me just comment this and let me just use this object. Okay, so uh, okay, format. Is there any issue here? Yeah, we need to create the object actually. So const thenable. Okay, now let's do promise dot resolve, and we can just pass thenable and call the then method, and we can pass the console dot. So usually what happens with promise.resolve static function when we pass a non-promise value, the fulfilled value will be the non-promise value. Here it's a non-promise value, but the thing is this is a thenable. So normally we would expect the console.log would print this object as it is, but it is not. So let me save this and see the output. 15 is printed. So that happens here. So here as well, when we hit the await, it uses promise.resolve and passes this object. But this time, this is not a promise instance, so it won't immediately return that object as it is, but it processes it. It calls the resolve function. So if that's the case, what happens? So there sometimes we have some weird then objects. So let's say this is a then, and it's just do console.log then is executed. Okay, just I'm adding just this. Okay, nothing else. And what will be the output here? Okay, let me just save this and see what will be the output. So here you can see that then is executed and nothing else. You can see that there is a no delay, nothing going on. So we expect this console.log and it returns 5, then this console.log will be executed with the value 5, but nothing happens. Only this statement is executed, this console.log. Okay, now let's just mm, get the value here. Const uh, value. Okay, now here, what we can do here is um, console.log value and then value.then console.log. Okay, now you can see that this promise is pending. Okay, So this will be always pending. Why? Because here, this is not a normal object. This is a thenable object, and we have a then method inside. So when we pass a thenable object, of course, it process. How it process? It internally calls the then method with the resolve function. But here in this particular case, we are not using any of those values. We are just logging it. So this function internally calls with the resolve function, but we are not using the results. So unless we call the resolve function, this won't be in the fulfilled state. Unless this won't be in the fulfilled state, this always suspended, which means the rest of the code is not executed. Once it is in the fulfilled state, then only the rest of the code is added as a microtask. But if this is suspended as a pending promise instance, the rest of the code is not executed at all. So that's why we are not getting this value, and the return statement is also not executed. So this promise will always be in the pending state. So that concludes our async await deep dive video. I hope you have understood all the concepts behind async await, how it internally works, the conceptual transformation, and everything. Thank you for watching.